yeah, I'm Johan. I'm a crazy person from Sweden who is pretty much self-taught when it comes to programming and electronics, and I just generally do most things as long as it's related to computers and that type of stuff. Yeah.
Do you remember the exact moment you got hooked on computers?
Oh, that's a bit of a story, isn't it? I mean,
It
first,
really is.
time I used a computer must have been 79 or 80. A cousin of my dad had an Apple II. I do remember playing some games on it. First time I really started using a computer was my mother's husband had a Commodore 64. First game I remember playing was Willow on the C64.
Oh, Willow.
Punishing game. Not Willow from the movie. It's another game called Willow.
Okay, yeah.
Yeah. And the first time I really had my own computer, I got this one in 1985 on my 10th birthday. That's this exact computer, actually.
Yeah.
So, I mean, ever since then, there hasn't really been much else going on in my life.
Just computers.
Yeah, pretty much, and anything around it, really. I learned how to program on that machine. I started with Basic 7, learned from this fantastic manual, of course.
I can't really see it on the video. Can I take it more? Yeah.
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 So that's the Swedish Commodore 128 system manual, which has all the basic stuff in it. This is, once again, actually the book I got with that computer. So this has been with me since 1985. So, yeah, and ever since then, it's pretty much been that way. Me and a couple of friends who had Commodore 64s, they started poking around with doing small demos in BASIC. Of course, we started competing on who was the coolest, of course. Eventually, I managed to pick up assembly, and yeah, there you go.
Yeah. Okay, what other computers did you have in the past that are now considered retro?
Oh, once again, that's a matter of had and used. So I started with my 128 in, I think it must have been 1990. I bought an Amiga 500 with a hard drive and a monitor at that point. I still have the monitor over in my garage over here. The Amiga is long gone, unfortunately. I moved from doing assembly programming on the C64 demo coding to 68,000 assembly on the Amiga, of course. Never really were any good as a programmer, but hey, you gotta try, right? From there, I later ended up buying a friend's Amiga 3000, which I used. That was my main computer up until what, 98, 99, I think. It was fully loaded. I had the Cyberstorm 2060. I had the Cyberation 64 network card. You name it. It was all in there. All the ships were updated. In fact, I bought the last DMAC 04 ship that Data Companiet in Norway had.
Yeah, I remember that company. I bought out the remains of them some years later.
I bought the last DMAC 4 ship they had in stock back in the days. I later sold that machine to actually a Norwegian. I was working at a call center at that point, and went full PC for quite some time. And I'm not going to go through the whole PC history because they're just boring utility machines.
Correct.
And I've been using PCs almost exclusively up until what, 2019, 2018, 19 or so. We'll get back to what happened then and later on, I'm sure.
Do you have any of those computers still outside of the 3000?
The 3000 was sold. It's. I don't generally regret selling things, but the one thing I do regret selling is that first Amiga 3000. It's not so much for the computer itself, but also because I had SASE original, Storm C's original, I had this huge pack of original software as well, dev pack free, all the ROM kernel reference manuals, etc., etc. And it's taken me a lot of money and effort now to rebuild that collection that I had.
I can imagine.
Yeah. So, yeah, I do have a inordinate amount of Commodore 128s, of course, of all sorts of varieties. I don't even have an accurate count. There's too many of them. I have an Amiga 1200, a 500 plus, the Amiga 3000 that I built, a 64 Ultimate, and yeah, just a few other bits and bobs. It's primarily Commodore centric, of course, but I also have started collecting some old Swedish computers, the Luxor ABC series. And the odd machines that you run across and just, I mean, I found a Silicon Graphics O2 sitting in a skip at work. They were going to throw it away, and I just went, nah.
No.
That one comes home with me, so it sits in a cupboard here. Yeah.
Great. Over to where I met you, AROS.
AROS, indeed, yeah.
What pulled you into AROS originally? AROS, however you want to pronounce it.
Yeah, exactly. I mean, back in those days, that must have been what? Early 2000s?
Yeah, the project started in 96, I think, but nothing really happened until...
AROS started in 96, yes. But I think we met somewhere around 2000, 2001, it must have been.
Probably on ERC or on my forum, perhaps.
It would have been on IRC, I'm sure.
Yeah.
So I started digging into AROS a bit, just because back then, as you can probably tell, I was still a bit of a foaming at the mouth Amiga zealot, like we used to be. Yeah. And but I'm still of the same opinion. I don't really have that much of an attachment to the Amiga hardware per se.
No.
I mean, it was really cool hardware for its age, absolutely. I do not think it would have had a future regardless. It was just too integrated to be able to upgrade and expand over time. That's kind of the drawback of the Achilles heel of the Amiga architecture, if you will. But the software Amiga OS, there are still things I miss from Amiga OS in modern operating systems.
Yeah, same.
I mean, something as simple as assigns, there is nothing like it anywhere else. So yeah, and as Amiga was by that point, early 2000s, I mean, it was dead and dying. Yeah, there was too much infighting. You had the whole Hagen partner malarkey going on, and
I remember those days.
Yeah, the few remaining commercial vendors were too busy suing each other rather than actually doing things.
Correct.
I remember most of the Atari enthusiasts were laughing at the Amiga folk because they just did things. They didn't argue and have wars. So I kind of realized as part of that, well, Amiga was, if it is to have a future, it needs to be open source.
Yeah, I agree.
I found AROS and I started working on it. And remember back then, AROS was primarily just something you ran on top of a Unix. So you installed Linux, you compiled AROS, you typed aros.exe in essence, and it would just pop up AROS in a window.
Yeah, you read it hosted, as they like to say.
Yeah, it was an application, pretty much. Yeah. So I started digging into that a bit. And around the same time, Michal Schultz started working on writing the x86 PC kernel for AROS. And as I said, I happily admit I'm not exactly a great programmer.
No.
But I am fairly useful as a utility programmer. So if you come up with an architecture and a design for something, I can happily fill in the blanks, as it were. Yeah. So as Michal was working on the nutty parts of writing the kernel, all the memory management and all of that jazz going on, initializing the CPU, I started helping him out by working and fleshing out the drivers that he had written. So he had written a rudimentary IDE device, but we didn't have any code to read partitions, for example. We didn't have a way of really bootloading the kernel. We were just chain loading it at that point. So I started helping out. I wrote the AROS uses grub multi-boot standard to boot itself. I wrote the initial implementation of that, the bootloader.resource that we have now. I wrote, and I finished, I wouldn't say I wrote the IDE device, but I certainly finished it up to working order. I've wrote the partition management, so parsing the partition table and being able to boot from it. I fleshed out track disk device. And in fact, I think I'm one of very few people who have managed to get a PC to auto-detect floppy inserts.
Oh.
Unfortunately, due to the way PC hardware works, you can't do no-click on them. So it will click.
Yeah.
And you have no choice of actually making it go away. So I think they actually disabled that part of the track disk device in AROS now. But the code is still in there. It's just disabled. Yeah. And then finally, once I had the bootloader stuff sorted out, I brought the first VESA HID. So for people who don't know, HIDs are the way that AROS does device drivers. It's a bit of an interesting concept. They're actually object-oriented drivers based on the manual object orientation system from Intuition, Bootsy. So to write a basic display driver, I don't have to implement all the functionality as long as I can initialize the screen to report a list of resolutions, initialize a resolution, and have a put pixel and get pixel. All of the other primitives are basically just superclassed. So the upstream has a software implementation of drawing a line, drawing a circle, and all of this type of stuff. So I don't have to do it in the drivers unless I can accelerate it.
Yeah.
So it's a fairly clever system. Bit awkward to work with, but it works. It really works. So yeah, that's my AROS history basically. The one claim of fame I can do is probably that the first time AROS booted natively to a full graphical workbench and working was on an old Satellite Pro of mine in my bedroom, as far as I know.
Cool. What was the most satisfying piece of code or subsystem you contributed to?
In AROS? That would be a toss-up between track disk device, which was enjoyable and hell at the same time because PC floppy controllers are batshit insane. They should not exist, and I do not wish to inflict them upon my worst enemy.
Okay.
One of the problems with them is the hardwares are all buggy in different ways.
Yeah.
And making it work in QEMU or VirtualBox or whatever does not mean it will actually work in real life on real hardware. So lots of fun. But I would also say that the whole bootloader part of it, using grub multi-boot and passing things on, that's used fairly extensively now in AROS, where you can actually load modules from grub. So you can basically just tell, I want to have these parts loaded. Grub will load them for the kernel, and the kernel will then go through the structure and see, okay, I have these modules loaded. So that's part of the multi-boot system. I'm actually not aware of any other operating system that uses multi-boot to that extent. It's in the specification, but I've not seen anybody else use it.
At what point did your active involvement in AROS start to slow down?
Oh, that must have been 2004, 5-ish, I think.
It's been a while.
It's been a long while. I mean, that's 20 years ago now.
Yeah.
It started slowing down mostly because people around were also slowing down. I remember discussing with Michal, we were both of the same general opinion that the problem with AROS or the kernel code that we were writing is not so much the kernel code, which is fairly straightforward. It's writing the drivers.
No.
You're ever lagging behind having to write the drivers, and you can't use Linux drivers because the APL, the AROS public license, is not compatible with GPL. We can look at BSD code, so we can use BSD licensed code, of course.
Yeah.
But BSD drivers are gorgeous, but they suffer from the same problem. They don't support all the hardware they would want to do, graphics cards and what have you. All of that is in Linux, and the license in AROS was not compatible. In fact, for some time, I actually tried to collect up the signatures of developers to try and relicense AROS into a different license.
Yeah.
The most commonly accepted among most of the developers I chatted to was LGPL.
Yeah, I remember that now.
Yeah, because you had all of this malarkey with, this was the era when Amiga Inc. was still in full business, and we had to rename it from the Amiga Research Operating System to the Amiga Replacement Operating System to the AROS Research Operating System, and it wasn't on GitHub because we had promised not to put it on public repos, and it was just all this kind of concessions to Amiga Inc. And I think the licensing was part of that as well. I was never really happy with the APL itself. So eventually, I just kind of petered out. I still remember a lot of people from that era very fondly. One person in AROS land, especially in early AROS, that I never think got the kudos that he deserved was Georg Stegen.
Yes, I think
because he was just silently sitting in the background, fixing everybody else's code and cleaning things up and just doing all of that busy work that nobody wanted to do. But he just did it. Yeah. So
I remember him. There was quite a lot of people coming and going as well.
Yes, he was always there in the background, just working alone. Yeah.
How do you feel about where AROS is today compared to when you worked on it?
There have been improvements, but to be honest, I don't feel anything has really changed.
Too little, too late.
It's just there's work going on. They're hampered from my perspective, and that was also another big thing for me with AROS: the license and the bloody build system. I do not like how AROS is built. I never liked MetaMake. I think it's a stupid idea. I'm not too fond of the whole mega repo idea, where you have the entire distribution in one single repository. So it's part of that, the fatigue of dealing with that honestly batshit insane build system. I mean, it was good when it came out, but I was working quite a bit on actually migrating it to scones or some other more modern build system. Because for me, that's also the license, and that build system is also what's kept a lot of people away from contributing to AROS.
Definitely.
Yeah, and eventually that just wears you down, and I just slowly started giving up on the whole thing. So we were talking, me and Michal, for a while about developing something called ARIX.
I think some people have created something like that now.
Michal has a repo in his GitHub called ARIX, which is pretty much that idea. So our thinking was basically, we'll take the AROS user space and put it on top of a Linux kernel. But we're not going to use glibc and all of and make it a user space application. We will use the AROS user space directly on the Linux kernel. So you will have an exec library that will just call memory allocation routines in the Linux kernel. You will have disk. You will still have your block layer devices. So DOS would then have a translation layer to devices, and the devices would then do syscalls to the Linux block layer. So that's a way of getting that clean. We can have the Linux kernel GPL, but since we're only using the official API calls of it, it's not a problem mixing it with AROS, because it's not a derivative work. We're just using the kernel as it's intended to be used. That's a good way of getting around the whole driver issue. But once again, it's the amount of manpower needed to do something like that, and also a lack of interest from the community in general, because they just see Linux and go, no, that's not Amiga. Never mind that what's Amiga, it depends on person.
That's right. Do you still follow the project at all?
Only peripherally. I have a look at it every now and then. I download one of the distros. I have a look at it. And yeah, I said, I don't really feel there's much going on.
Okay, let's go to something you are burning more for, the 128 Neo.
Oh, yeah. Yeah, one of those.
One of those. Let's see here. The machine is already pretty unique in computing history. How did you first become interested in recreating or working on a modern reproduction?
That comes back to what I was talking about earlier in 2019. So, as I said, I still have my first 128, which is my first computer. I've been dragging it along as I've been moving houses, etc. It's been in the banana box. We all have banana boxes full of stuff. So, but I've never really kept it outdoors or anything like that. I've just kept it inside. It's been in my garage. It's been in storage closets. But it's been fairly well kept because, hey, it's my first computer, right? In 2019, I got a bit interested because every now and then I just do a bit of assembly programming because 6502 assembly is kind of my home ground.
Yeah.
So I tend to fire up just Vice and write a bit of code every now and then just for fun. So I decided to just do it on the 128, the real one, just for fun. Unpacked it, plugged it in, turned it on, and I get a black screen. The classic Commodore 8-bit curse, black screen.
Yeah.
And yeah, as I usually say, the repair of that black screen has snowballed a bit and gone a bit weird.
To say the least.
Yes. So at this point, I was also aware of Rob Taylor's work. I don't know if you know about Rob Taylor. He's the British dude. Who
Yeah.
The 60 clone and the A500++ and other replica PCBs. So I've been chatting with him a bit. In fact, I have bought a 500++ board to stuff. Populate with components. We usually call it stuffing. So yeah, I was aware of that. I was aware of I've chatted a bit with him on Discord at that point, etc. And as I worked on fixing my 128, I started realizing that my problem, the actual issue with my 128 was corrosion on the PCB. And this is not machines that have batteries or leaky capacitors or something like that. It's just a standard 8-bit machine. So what happens there is the solder mask, the green color on the board, it's called a mask because it's supposed to mask the copper away from the oxygen in the air. Because if you had raw oxygen, of course, it would just turn into that green stuff that copper turns into, which is not good. So you paint the solder mask on there, which is supposed to be a barrier for the air.
Yeah, but time.
But of course, it's not 100% airproof.
No.
It might be 99.999% airproof, but it's not perfectly airproof. And on top of that, if you had a bit of condensation or spilled something on there, you will get even more aggressive action. So a couple of traces on the 128 board have basically corroded away. Just from sitting around.
Yeah.
No battery leakage, no capacitors, whatever, just from sitting around. And it had been stored fairly well. So I just going, well, if that happened to mine, I'm sure it's happened to other people as well. And Rob Taylor has made these clones.
Yeah.
And if he can do it, so can I.
Yeah.
So I just fired up KiCad and started working on making a replica board.
Just like that?
Just like that, yeah. And to be fair, my experience with electronics at that point was just basic digital electronics.
Yeah.
So I could add a reset button to a Commodore. I could design some simple logic circuits, make an LED blink, do a bit of address decoding, just the basic electronic stuff. I was fairly good at soldering, but not so much on the design side. So, doing a Commodore 128 replica as your first electronics project of any form of size is...
Sounds a bit overkill.
I would say I wouldn't recommend it, but then again, if you're a person like me, the experiences and what you learn through the journey has been absolutely immense.
Yeah, so you had a lot of fun.
I'm very happy I did it. Of course I am. Has it been a lot of work? Of course. I made so many mistakes during the process that it's just insane, right? I'm still cleaning up things because I'm still working out of the same keycap repository. And I compare it to newer projects and I'm just going, oh, God. It's the old code syndrome, you know?
Yeah.
Why did I do this? Jesus.
Yeah.
So, no, that's the way it worked. And it just kept on rolling from there. It's whenever I found a little side project or interest related to it, I just jumped in head first and never looked back. So it's gone absolutely crazy.
What exactly is the 128 Neo in your own words? How would you describe it to someone that's unfamiliar with the project?
Oh, yeah. One thing I do, so like a lot of us in IT and in vintage computing in general, I'm on the autistic spectrum, of course.
Yeah.
I also have traits of ADHD, so I have a hard time keeping focus, and I'm very easily distracted. So one thing I have learned over the years is whenever I start a project, I always set a mission statement before I start. And then I stick to that. Otherwise, I will end up with never-ending feature creep, and I will never, ever finish. So the mission statement for the Commodore 128 Neo was to be a one-to-one replica of the Commodore 128 PCB with the factory budgets merged into the board and some small quality of life things. That's really it. So it's literally intended to be a full one-to-one replica of the Commodore 128 board. If you have a broken one, you can take this one, move the components, and you have a working 128 again, which looks and behaves identical. So no changes to memories, no changes to adding a double SID or something like that. That's out of scope. So, and I have nibbled maybe a bit on the edges on the quality of life with a couple of features on the latest ones, but I still think it's been going accordingly. The other thing I was sure of from the start was it would be open source. So once I had reached a level of maturity on the project, which was for me was revision 3.3, which was about 2 years after I started the project. No, a year and a half, maybe. Must have been, 21, 22? I can look. I basically decided that, well, this is good enough. This is almost identical to the original board. I will release this as open source. So you will actually find it as a public repository called Open 128. It is identical to the 128 Neo revision 3.3. You get all the keycap files is public Creative Commons licensed. No commercial clause. You can do whatever you want with it. The only real differences between a 128 Neo and the Open 128 of the same revision, so the revision 3.3s, is the silk screen, so the artwork on the board. That's the only difference. Otherwise, they are 100% identical. I have since kept working on the Neo 128 and added a few more quality of life things. So RF modulator, nobody wants to use the original one. So I integrated the circuit of it onto the board. Optional. I added extra pin headers on the latest revision 5, which I will start selling shortly. I've also changed the power connector because the Commodore 128 uses the same square power connector as the Amiga 500. And you can no longer buy them.
That's true. I remember that now.
Yeah, you cannot buy them anymore. Jens Schoenfeld has a small stock. He will sell one per customer. And he is the last one to have any, because when he placed that order, they eventually broke the casting mold.
Okay,
the injection molding tool they were using to make them. So if you want to have more, you will probably need to order 10, 20,000 of them.
That's not going to happen.
No. So what I did was I changed the 128 Neo board to use a Commodore 64 power connector with a Commodore 64 pin out. It's not compatible anymore, but you can still buy adapters from the 128 connector to the Commodore 64 connector. So you can still use the Commodore 128 original brick, and there is also plenty of really good aftermarket C64 bricks that will happily run a 128. And those connectors you can still buy.
Yeah.
So that's what I mean with the small quality of life type things. Yeah.
Very understandable. What was the hardest technical challenge in recreating the system?
Technically, it wasn't that bad, actually. It was mostly for me to develop the skill set of using KiCad and getting used to how PCBs are manufactured and what you should do and what you should not do.
Yeah.
The Commodore 128 itself, you have the schematics in the service manual and in the programmer's reference guide. They are incredibly accurate for its era. There's only 2 things on the schematic I know that were not correct compared to the board itself, which is almost incredible. And one of those things is just that it's missing a circle on an output of an inverter gate. So that's not exactly a mistake.
Oh, no.
No. And the other one is a jumper where the schematic is correct, but the board is not. So once again, the schematic is how it's supposed to be, but the board does not actually match that schematic. So I started by just importing and drawing the schematic in KiCad. And trust me, the first versions of that was a gargantuan mess. I have spent a lot of time cleaning that mess up ever since. But that's normal. You're learning the tools, etc. And then it was just a matter of getting good. What you do is I just populate the board, remove all the components from it. I slap it in. At that point, I used the flatbed scanners at work on the big A3 multi-function printers to get scans of it. Nowadays, you can import a scan like that as a background image in KiCad, which makes life easy. Back then, I actually had to convert it into a single bit plane, so a monochrome image, and convert it into a component, which would make it run at about 5 FPS. It was absolutely horrible. But once you have that done and the schematic is correct, it's literally just a matter of placing out the components, and then you just put on the headphones, grab some nice music, and sit and click out traces for hours and hours and hours.
Oh, sounds fun.
Yeah, so from start to finish, the 128 Neo took me probably about 3 months. Getting the schematic in
Not that much.
And laying out the board. Well, it's not that much because I already had all of the data I needed. I was just copying something. Yeah. If I had to do a full Commodore 128 board layout from scratch, I would still be working at it.
Yeah.
Because it's a huge board and it's complicated.
I can believe that.
Yeah. So no, about 3 months. I ordered some boards from JLC PCB in China, which is my main supplier for these. They're the only ones that looked at the size of the Commodore 128 board and go, yeah, sure, we can do that. Everybody else just screamed and started making hissing noises. Nobody does PCBs that large anymore. It's 16 by 10 inches exactly. It's huge.
Yeah.
So I got a set of 5 boards shot, which is the smallest order. I got them home. I soldered one up. The one big mistake I had on them was the AV DIN was not correct, so I couldn't actually insert the connector into it. So I had to run wires from the connector points. Plugged it in and it worked. First try.
Wow.
That shocked me. It's still surprising to me that it just worked. Perfect. Direct from start. So, yeah. So no, it wasn't all that technically complicated as such. It's mostly a case of just clicking along, as follow the line draw the lines between the numbers. That type of task.
What has user feedback been like from people that actually use it?
The people I've talked to be honest, you don't really get all that much user feedback. I've heard the same from other people who do open source hardware as well, and hardware replicas like this. If you talk to somebody and they have a problem, they approach you on Discord and you talk about it, yeah, they're very thankful and it's good. But you often really don't get a lot of spontaneous feedback. And with open source, it's the same thing. I basically released the Open 128. It's full open source. You can do whatever you want. And I was just expecting people to grab it and start replacing the 16 DRAM chips with 4 DRAM chips or a modern replacement and adding a second SID or whatever. I mean, must be better than trying to add all of these little expansion boards all over the place, right?
Yeah.
No, crickets. Absolute crickets. Nobody. I get some clones of the repository, but it's just for safekeeping. I get stars, but no pull requests. Nobody doing interesting things with the board. It's just...
That's a bit sad.
It's a bit sad, but I guess it's also understandable to some degree. It's hardware after all. There's a lot fewer people doing hardware designing than there are people doing software development, for example.
Yeah, that's true.
It's a bit harder to get into. It requires a bit more monetary expense. If I have a software bug, I can fix it, I can test it, I have spent zero money, and I can just issue a pull request and it will be merged and problem gone, right? Yeah. With a hardware project, you need to spend money.
Yeah.
Instantly. If I want to add a second SID, I will need to come up with a circuit design to make it work, probably do a prototype board or two of just the replacement circuit, then integrate it into the 128 design. Yeah. I need to run a test series of at least 5 boards to make sure that it actually works as a new board layout. And this all costs money. I mean, a run of 5 boards on the 128 Neo, the fewer boards you make, the more they cost each, of course.
Yeah, of course.
And a set of 5 boards, the normal small prototype runs I've done, that's about 200 euros shipped in my hand.
That's not cheap.
Yeah, and the first boards I started selling was revision 3.1, put it that way.
Yeah. Oh.
Yeah. So, I mean, there is quite a bit of upfront cost in this, for sure. And I think that's also why you get a lot less interest in contributions around open hardware projects, especially really niche ones like this.
Yeah.
And the 128 truly is niche. I mean, it is practically, for all practical purposes, it is a C64 variant because there's almost zero software for the 128 specific. There's almost zero hardware for the 128 specific. There's about 10 games and about 20 pieces of software for 128.
It's really weird that there is not more, because considering many units were sold.
Yeah, there were quite a lot of units sold, for sure.
Yeah, there was.
So it's well over a million, for sure. Yeah. So, but it is a very solid, reliable Commodore 64 with extra features.
Yeah. That it is. Have you had any reactions from long-time Commodore developers? And I know you have. So.
Oh yeah. It's part of. So early on in the project, I ended up actually getting in touch with Bill Hurd.
Yeah.
For just cautiously, because I mean, Bill Hurd was my idol since I got this machine back in the days. So I know he was involved in it, and eventually I cautiously reached out to him and said, I'm working on one of these. And Bill Hurd is a really cool man, by the way. Yeah. I absolutely, he's really cool to hang out with. So yeah, we started chatting, etc., etc. It's to the point where I start digging up these really weird, deep technical questions that makes him have to sit down and think about things nowadays, which he says is interesting because it jogs old memories that he's forgotten. Yeah, and from there, I mean, in 2022, you have this big vintage computer festival in the US, VCF.
Yeah, VCF, yeah.
There are multiple VCF events. One of the, not the biggest one, but one of the more classical ones is VCF East, which is held in New Jersey, in Wall Township in New Jersey.
Yeah.
And one of the reasons that one is pretty interesting is because New Jersey is neighboring Pennsylvania. There are a lot of old Commodore folks still in that area.
Of course there is.
Yeah, so ever since even back in the early days of VCF East, they've had Bill Hurd, they've had Greg Berlin, they've had Dave Haney, they've had all sorts of Commodore people coming and going.
Yep.
And so for 22, at that point, I've been chatting with Bill for a while. He just went, well, you're coming to VCF East, right? I'm just going, well, sure. I mean, that's an opportunity, right?
Yeah.
Going to the States, meet a lot of old vintage computer type people. So, I just went, yeah, sure, I could probably come. And he goes, oh, good. I booked you a table. And by the way, you're giving a talk.
You're giving a talk. Oh, yeah. Okay.
So, there I was on stage in New Jersey, giving a talk titled Reverse Engineering the Commodore 128 with Bill Hurd and Dave Haney in the audience.
Oh, the same one you did at my party then, Lores.
It's the same talk, yes.
Yeah.
It's been extended a bit for when I gave it at Lores, but yeah. So I did give that talk. It's on YouTube. Unfortunately, the audio isn't perfect, but it's there if you want to watch it. It's got good reception. So yeah, and also I had a table showing the 128 Neo and all the other things. There were quite a lot of people interested, of course. Met quite a few friends who I was still talk to at that event. And I've actually kept going ever since. I go to New Jersey every year in April. So, and also in 22, that was just in 2022, Bill Hurd had reached out to Al Charpentier, the creator of the VIC-2 chip, one of the co-creators of the Commodore 64.
Wow.
So he had reached out to Al, and Al had decided that, well, sure, I can come along. So my one bit of thing that I did was when Bill Hurd told me to come over there, I asked him which hotel he recommended, figuring he would recommend the one he's staying at, and yes, he did.
Yeah.
So on Saturday that weekend, I ended up sitting at a pizzeria with me, Dave Haney, Bill Hurd, and Al Charpentier, just talking about stuff. Later continued in the hotel bar, where we were sitting there together with, I think it was Fred Bowen, and a bunch of other people as well. And just talking about silicon engineering and Commodore engineering and all sorts of things. So
that must have been like a dream.
And that was just absolutely amazing, yeah. And of course, I met a lot of them since. I went to Amiga 38. First time I met RJ McCall, for example. Hi, RJ. He's a fantastic guy. So most of them are. They're just great people. And Bill Hurd has kept dragging in a lot of the old Commodore people back into the current scene, so to say. Often around VCF. So we had a talk this year at VCF East with old Commodore staffers, and that was the first time some of them were actually involved. So we had I met Terry Ryan, for example, for the first time.
Who was he?
Terry Ryan is the software engineer that developed BASIC 7 for the 128. He also did BASIC 3.5 for the 10 series, so the plus 4 and the Commodore 16.
Yeah.
He was told to not introduce structured programming, and he didn't. So one of the things I've done on the Neo board, and it's the part of the Neo board that I'm the most happy about myself, is I asked Bill Hurd which names he wanted to have on there, because I wanted to have all of the credits of the original developer. So you will find two separate sections of text on the board. One is the credits of the board itself with all the original Commodore people, And then there's a smaller one with my own personal credits for people who have helped me along the journey.
Yeah.
So, well, your name is on there, you know that.
Yeah.
And my general rule is any Commodore engineer, any Commodore person really, who wants a board will get one for free. Absolutely no questions asked, because I didn't create this, I just replicated it. Right?
Yeah.
And that was basically my meeting with Terry Ryan. It was just, oh, hi, Terry. I got something with your name all over it. And gave him a board.
That's a nice gesture.
For me, it's just, if they want one, they get one. That's absolutely. It's my way of showing respect.
Yes, of course. Do you have any more future plans with the project, or is it considered finished?
The one with the revision 5 that I will start selling now, the 128 Neo as a product is finished. There's nothing more I want to do to it. There's nothing more I want to add, change, or whatever. It's, for me, that's a finished product, right?
Yeah.
That edition of it will eventually also become fully open source at some point in time. Yes. I am working on things.
Yeah.
Of course I am. I mean, who stops, right?
Anything you can tell about?
I won't really go into a lot of details about it, but I am working on what I call a 128 follow-up. So what I haven't mentioned yet is, at some part during the 128 Neo project, I found a video on YouTube. About a man from France who had a different way of opening ICs. So ICs are packaged. The black stuff that you see in an IC capsule is actually epoxy. It's epoxy resin with silicon granulate that they use.
I didn't even know that.
No, most people don't. And if you want to get to the actual IC, which is a fairly small brick die of silicon inside of there, you have to get rid of that epoxy, of course. And the epoxy is designed to be non-permeable and resistant to any and all corrosion, right? So they're not easy to get rid of. In fact, industrially, they will use fuming red nitric acid at about 60 degrees centigrade, which is not stuff I want to have in my hand.
No, definitely
no. If I can even buy it in Europe, which I can't.
Probably not.
No, you can't, because it's considered a precursor and a hazardous material. So even if you're a company, you need to actually seek an authorization for it. No, hang on a minute. But Antoine basically had a video where he showed his way of doing it. So he works professionally doing microscopy. He actually inspects pollen for a living. Yeah. And as a hobby, he takes ICs apart and images the actual silicon inside. There's a whole community of us.
That's another hobby I haven't heard of, but okay, yeah.
Yeah. So at that point, I had a small soldering microscope that I use for soldering surface mount components and that type of things. Magnification is the most important part of soldering, as far as I'm concerned. Without magnification, you're always going to struggle. So he showed that by heating up the actual epoxy packaging to about 400 or 500 degrees with a hot air station, it becomes a bit brittle and you can break it using just a pair of pliers. And it depends on who made the ICs, but Commodore chips in particular are very susceptible to this. And so at that point, I'm just going, oh, hang on. I have stacks of broken Commodore chips. I mean, who doesn't? So I just figured, well, I can give it a try, and just broke open a Commodore 128 PLA, stuck it under my microscope at the max magnification I could get out of it, which is about 90 times, and was genuinely surprised by the amount of detail you can actually see, even with a cheap microscope like that. So, of course, I bought a bigger microscope.
Yeah, of course.
then I started figuring out that, well, this is kind of a complicated side hobby on its own. So now I have a new hobby. I started creating, because you can't take a microscope shot of the entire die. Once you get up in magnification, you can only see small parts of it.
Mhm.
So you need to take many pictures and stitch them together to make a whole die picture, so to say. So, of course, I started working on another hobby, which is CNC controlling the microscope, so I can automate that picture taking. So I started building up that, and eventually I managed to take a full set of pictures of the Commodore 128 PLA, which, as opposed to the Commodore 64 PLA, was not known.
Mhm.
We did not know the logic equations of the 128 PLA. And so I took it apart, and then I started reading up on how ICs are actually designed and manufactured, which is yet another one of those interesting hobbies. Eventually, I managed to find this book, Introduction to VLSI Design by Conway and Mead. Lynn Conway is the primary author of it. It's from 1970. I can't remember what to say. 1970, late 70s, somewhere. Anyways, it's a really old university textbook from the late 70s on how to design and manufacture NMOS, which is exactly what all Commodore ICs are, with very few exceptions. So I started reading in that book. I wasn't really interested in learning all the meticulous mathematical detail on how to design an IC, but it taught me enough to be able to look at an NMOS IC and figuring out what is what. Here's a transistor, and if they're hooked up that way, it turns into an inverter, and all of these type of things. So eventually, I sat down and I just reverse engineered the logic of the 128 PLA. So just from looking at the IC itself. So that's a weird hobby. There's a few of us.
I would say.
There's pretty much only two people who do that for a living. One is security consultants, mostly working on modern chips. And the other one is vintage computing enthusiasts, because we need to take them apart to figure out how they actually work.
I guess that will be the end of the 128 questions. One question I almost forgot about. You also help out at the museum. Can you tell us a bit about that?
Oh, yeah. So when I flew over to VCF East, this is once again Bill's fault. When I flew over to VCF East in 22, I decided to, the event starts on Friday. But I decided to fly over on Wednesday so I wouldn't be completely jet lagged for giving the talk on Friday, because my talk was on Friday. And I woke up on Thursday morning in the hotel and I was going, I'm bored. I don't know anybody over here. So I called up Jeff Brace, who's the event organizer, and he goes, do you need a hand? And he goes, yes, please. So I just drove over to them, to VCF East, where the venue, and helped out with basically just setting up the event, unfolding tables, putting out tablecloth, all of that type of jazz. So that led to me being treated as part of the crew over there. I was let into their warehouse and see all the stuff that you never see as a normal person.
Oh, nice.
They treated me really nice and gentle, etc. I had an absolutely fantastic time, and helping out is something I've done ever since as well. I usually fly in early so I can help them set up the event, mostly because I like the people. They're nice and friendly. And I'm just generally having a good time. So when I was flying back from that first event in 22, I was just going, I really like that. I want more of that camaraderie and just, And I knew, because my wife has two daughters living in Eindhoven, which is close to Helmond, where the Home Computer Museum is. I knew from driving over there that there was a Home Computer Museum in the area. I've been driving through Helmond a few times. And even seeing the Home Computer Museum scrolling by on the navigation map. but I just never took the time to go in there. And eventually, must have been 20. Yeah, that was in 22. Later on, about a month later, I just walked in there one day and met Bart, the founder of the museum, and we chatted for an hour and a half. He gave me a round tour.
Yeah.
And ever since, I go there at least once a month, trying to help out, etc. Because there is a fantastic crew as well.
Yeah.
And if you are ever in that area of Europe, absolutely, you have to go visit that museum. It's homecomputermuseum.nl.
Yeah.
In Helmond, close to Eindhoven.
Yeah.
It is absolutely fantastic. Unique in many ways. It's probably the world's largest home computer museum at this point.
Oh, it's that big.
It's really, really big. And we have, on average, about 400 computers that are turned on every day.
Oh. The electrical bill sounds crazy.
Oh, yeah. It's one of the expenses, yes.
Yeah.
No, because for us, it's important that people actually get to use the machines.
Yeah.
So if you have a good memories of an old Atari ST or a specific version of the Mac or an Amiga or an Oric or Acorn or whatever, we usually have one turned on that you can just sit down and play with. If there's a piece of software that you remember fondly, you can go and ask one of the staff and we will try and help you find it if we haven't, etc. So
everyone should go there if they have the possibility.
Absolutely. I strongly recommend it. Yeah.
For something else, do you think the internet has changed creativity for the better or worse?
Difficult question.
Yes, it is.
Yes. I'm old enough to remember how it was before the internet.
Me too.
Yeah, exactly. I've already passed the big 5-0, so there you go. So, yes and no. Before internet, we were always struggling with finding information. Like me and my friends working on writing demos, etc. I mean, when we were still poking around in BASIC, it was really our own creativity limiting us. Once I started getting more used to assembly, the advantage of the C64 is you just reset it, start a machine code monitor, and have a look at what somebody else did.
Yeah.
Because reading assembly is as easy as writing assembly on that machine.
Easy. I wouldn't call it easy, but okay, yeah.
6502 assembly is fairly easy. There are 58 instructions. There are 8 addressing modes. It's very straightforward. It's probably the last CPU where you can keep all of it in your head.
Okay, yeah. If we would say so.
Without being completely crazy. Yeah. But it was always troublesome finding information about things. You could go to the library and borrow books. Yeah, we used to have libraries with lots of
BBSs.
Or BBSs if you were rich enough to have a modem, yes. And parents who didn't mind
why I
squeaky
opened
noises.
one.
Yeah.
Calling was too expensive, so let's open one instead.
Yeah. And then we entered what I usually call the early internet.
Yeah.
So late 90s up until, I would say, about 2010, I would say. You had a lot of things going on. You had Usenet still being very active and a very good place for discussions. You had IRC for the more direct day-to-day chatting with people.
IRC was great.
BBSs, forums and online BBSs freaking everywhere. Yeah. It was a fantastic place. I really miss that early internet. Somewhere around late 2000s, early 2010s, it took a bit of a downturn and turned into this commercial mass surveillance heap that we have today. It's not just the internet either. Much of Western society's turned into this hyper-capitalistic need to make more money. What's the advantage for me? Rather than if I look at the late 90s, early 2000s, we were all optimistic and fairly altruistic. Well, data needs to be free. It was just generally accepted. Sure, we were pirating software front, left, and center. Of course we were. But it's and on creativity. On the other hand, if I look at modern tools, so I look at Git, I look at GitHub and its equivalents. I've stopped using GitHub myself. I'm now in Coldberg in Germany. That has massively improved collaboration in projects, especially software projects, but also in projects in general. It is a lot easier today to find like-minded people and collaborate on it. But you also have much, much larger and larger centralization. Everything is on GitHub. Everything has moved into Discord, and Discord is, like most of us, I like the capabilities of Discord.
Yeah, same.
I don't give a toss about Discord, the company.
Correct, and same.
I have problems with the fact that it's pretty much an information black hole.
Yeah.
Anything you put into Discord is in Discord and nowhere else. You can't get it out. And that's going to be a loss at some point in the future. If Discord decides to shut down, the amount of information loss will be gargantuan.
Yeah.
Whereas with old forums, I mean, many of them are still up and running.
Yeah.
And all the data is still there.
And some can be found via Wayback Machine. And
Exactly. Exactly. That's kind of my point. You can't do that with any of Discord. It's the same thing. I mean, fairly common back in the days. We had IRC bots that would just collect logs and put them on web pages.
Yeah.
Those days are sadly gone.
They are gone. So I would say it's positive and negative in many ways. I mean, you look at more simple usage. Back in those days, we were playing Eye of the Beholder 2, and you were drawing maps on your on your paper notebooks just to keep track of where you were. You don't have to do that anymore. So
people
in that way, we were trained to be more persistent and just go for it.
Didn't give up.
We didn't give up in the same way. No.
Now games are so easy that there's no point in playing them.
Games adapt to you, not the other way around. So they I noticed that in my sons, sometimes they play really old games to feel a bit of a challenge.
Yeah.
Because the sense of accomplishment you get when you actually finish something that was genuinely hard,
that is much greater.
Is completely different compared to a modern game where you know you're going to finish it because the game will just lower itself to your level.
Yeah, correct. What are your thoughts on AI?
First off, I reject the term AI.
Okay.
They're LLMs.
Okay, yeah, okay.
Yeah, they're large language models. There is no intelligence in there.
Okay.
They are, this is something I feel a lot of the AI bros keep forgetting. They are token generators. They do not understand anything. And in fact, the best way of looking at them, as far as I'm concerned, is they're a huge multidimensional Excel sheet of probabilities. That is a simplification, and is also a bit of a lies to children.
Yeah.
But that's in essence what they are. If I have this bit of text before me, or these tokens, the probability of the next token being is this one.
Yeah.
That's what they do. They do not actually understand the topic that you're talking about. They just work from probabilities based on the training material that was used, which can generate really surprisingly results. But I'm also old enough to remember the old ELIZA chatbot, right? And the ELIZA chatbot was written in BASIC back in the early 80s, if I remember correctly, or heck, even if it was even back in the 70s. Where it basically just has a couple of simple questions. How are you feeling? And how was your day? And then it will just pick a few of your sentences and play it back. How did you feel about blah, blah, blah?
Yeah.
And you would be surprised how many people will actually even start getting attached to something as very simple as that.
I know that's pretty sad, actually.
It is, but it is also part of human nature. It's just the way that things are, and because we attach more emotions to things than what they are. I mean, I have the same thing. I absolutely adore my cat.
Yeah, but it's a living thing.
It's also a little bit of a thing, but if you actually stop and think about it objectively, unlike a dog, a cat doesn't give a shit if you're living or not, in general.
That's true.
Yeah, as long as you provide food and a bit of comfort and cuddling and petting every now and then, he's happy.
Yeah.
Whether that's from you or from the neighbor, cat don't give a shit.
Correct.
You know? Yeah. So, yeah. I mean, I attach a lot more emotion towards my cat than he attaches back to me. And that's kind of the same dichotomy you see with modern LLMs. People attach a lot more emotions towards the LLMs than you get back out of it. That's from the chatbot type perspective.
Yep.
And the other thing I would say, it is a tool.
Yeah, it is.
It is incredibly useful
Yes,
and
it is.
advantageous to use for software development, for example. Vibe coding is something that's never going to end up well. Because once again, it's absolutely perfect for doing small detail work.
Yep.
I need a function to do with these inputs to generate X output.
Yep.
An LLM will provide that to you perfectly fine. It's just detail work.
Yep.
If you tell it I need a great big honking application to be a 3-dimensional CAD platform, you will get garbage.
Yeah.
Because it's not capable of designing something that large.
But will it be in the future?
No, not with LLMs. There will for sure be a different kind of artificial intelligence approach later on.
Yeah.
That will be capable of it. Of that, I hold no doubt whatsoever. But LLMs have reached their maximum already, as far as I'm concerned.
Yeah.
Because the other problem LLMs have is they need training data. Because you're training the probability matrix. That's what you're doing, right? And they run out of training data. They've already scoured the entire internet. They've stolen everything from LibGen, etc. Right?
Yeah.
Facebook downloaded 80 terabyte of things from Anna's library, right?
Yeah.
And meanwhile, Aaron Schwartz gets thrown into prison for copying 70 gig of data. Yeah, that's. Yeah. Anyways, we're not going to go political here.
No.
So, and the problem they have now is, and it's the same problem that we see as well. Anything on the internet today is tainted with LLM generated slop.
Yes, it is.
Yeah.
You
look at forums.
Problem.
You look at forums. It's slop.
Yeah.
It might not be a bot posting the slop, but it might be somebody who's generated that slop.
Yeah.
Reddit, I would not be surprised if somewhere between a quarter and a third of every post on Reddit is AI generated.
Oh.
You see a lot of AI generation even being used in local languages. I've seen it in Swedish forums, for example. A lot of AI slop being there. Artists are having huge problems now having to prove that what they do is not AI generated. You literally have to post a video of you creating your piece of art for people to believe that it wasn't AI generated, which is crazy. So the problem with that is there's no more training data for them to use. Because if you start training AIs on AI generated slop, you get what I usually call Habsburg AI. It turns into inbreeding. The quality will drop drastically of the outputs, and that's already been shown. So they run out of training material, and LLMs are pretty much, I'm sure OpenAI and Google and Microsoft and the other who create these models are sitting on gargantuan treasure troves of pre-taint material. They probably have a copy of the entire internet from before.
Yeah, I would think so.
Yeah. But as I said, there's only that much data to train on.
Yeah.
The training methodologies might improve. It will probably get slightly better. but they're also approaching their financial maximum. So I read an article just the other week. The current AI industry have spent about $1 trillion to generate 37 billion of revenue. Revenue, not profit.
Yeah.
So at that point you go, yeah, it's not exactly financially viable, is it? No. And the crash will come inevitably. Because we're currently I still remember the dot-com boom and the crash that came after that. Yeah. We're right at the peak of the dot-com boom, except now it's the AI boom. It will crash hard through the floor. And then eventually, in 4 or 5 years, somebody will pick up the pieces and start building actual working technologies out of it. It's the same with all the booms. They all follow the exact same curve. So it's going to be rough. And you can see the same. The quality of the training material is what makes it so good at code. Because the training material for code is always something that a compiler will accept. So by its pure definition, source code is high quality training material. Even if the code itself is pretty shit, a compiler will still accept it. Whereas if you troll a forum, you will get all sorts of randomness comparatively. Because a compiler is a compiler and it doesn't care about your feelings.
Yeah, right.
Yeah.
What current limitation in hardware or software do you think will be solved next?
Oh.
Good one again.
Yes. Splitting that up. Software is probably the easiest, I think.
Yeah.
Software as is developed today, I think, has a bit of a limited trajectory. Today, the entirety of software engineering is geared towards feature velocity. How can we get features onto the market the fastest to beat our competitors, etc.? Fixing bugs, making high quality software, etc., is not even on people's radar. It's just how can we get the features out? Yeah. You start already seeing some regulatory pushback against it. EU is currently working on a regulatory framework for making software companies responsible for their software. Yeah. And that's something I think you will start seeing more and more of. So at that point, the impetus for software companies starts changing from having the best feature velocity to making more reliable software. And I think you will start seeing more of a dismantlement of the abstraction layers, because right now we have so many layers of abstraction that software development is a leaning tower of Pisa. Yeah. And as the classic XKCD joke goes, somewhere at the bottom is that one lonesome dude out in the forest in Georgia maintaining the critical project that everybody uses. Yeah. And that's true. It's often the case. Open source has a huge challenge ahead of it. That's probably one of the biggest changes I see in software. As I said, LLMs are extremely good at creating software. And we've already had examples where people have looked at an open source project, been unhappy with a license or whatever, told an LLM to make the exact same project in a different language with a different license.
I hadn't thought about that, actually.
No, because one of the primary drivers behind open source code in general is it's easier to adopt an open source library than writing your own code. If an LLM can generate that same library code instantly with your own preferred license and everything else, GPL loses a lot of its potency. Yeah. And that's already a big challenge that I've already started seeing showing up. So that's going to be a huge one. For sure. And it's also important with how, because the legal status of code generated with LLMs is not really defined yet. Because once again, it is a probability matrix, but that probability matrix comes from all of the code that was stuck into it.
Yeah.
If that's GPL code, then what license is the output covered by? It might copy certain parts in verbatim.
Yeah.
So it's a very difficult legality point of thing that's still to be resolved. And that for me is the biggest part that you're going to see in software going forwards.
How well then?
In hardware, that is much more difficult to predict because you don't know what breakthroughs are going to happen. In large computing, so data centers, etc., I will expect that the development of optronics will continue. You're already starting to see a lot more optronics going on. So that's basically using light instead of electrons, or photons instead of electrons to actually do the computing.
Yeah.
You have fiber connections right into the IC. There are projects going on in that side on the research level.
Yeah.
You will start probably seeing democratization to some degree of silicon. So if you compare to 20 years ago, making a hardware project 20 years ago was much more difficult than it is today.
Yeah.
Today, I can fire up KiCad, I can sling together a project, I click one button, and a couple of days later, I have a set of PCBs in my hand.
Yeah.
And it's cheap, really cheap.
Yeah.
Sure, it's from China, but it's still really, really cheap, right?
Mm-hmm.
Small boards under 10 by 10 centimeters, if I want 5 of those, I'll pay a couple of dollars.
Yeah.
Yeah. And those are professional quality boards. So I would say that's already been democratized to some degree. There's also a lot of interesting projects now going on with printing PCBs at home. So making your own PCBs at home effectively. We can already do this to some degree, but there's one big problem that has not yet been solved, which is vias.
Yeah.
So making a single layer board is easy peasy. Once you want to use a 2-layer board, it becomes difficult because of the vias. You don't want to sit and solder little wires between the 2 layers and all the vias. That's just not going to work. And doing that type of plating process to generate a functional via is tricky business.
Yeah.
But I've seen a lot of people, really clever people, now working on it to make it basically a 3D printer for PCBs. So it's being worked on, and that's going to be important. And you see some of the same for silicon. You already have Google, for example, now running. I can't remember what they call the project, but they have a project where they manufacture silicon.
Okay. Yeah.
So you get the development kit, NDKs as they're called, for developing hardware, with the rules and limitations of the silicon process that's being used. You can design your own chip, and I've seen people do a Z80 and all sorts of other things.
Yeah.
Google will then, I think it's quarterly, or if it's monthly now even, do a production run of wafers with a bunch of those designs on them. And you will get 100 chips out of it. And it doesn't really cost you anything. And that means you can now start making custom silicon.
Yeah.
Which, for a hardware point of view, is going to be more and more important over time. I'm also aware of a few startups that are working on democratizing this to the point where you will get machines. Sure, they're going to be large, right?
Yeah.
Yeah, but the original thinking is, for making small-scale prototype runs of silicon, you should be able to just buy a machine, stick wafers in on one side, and get produced ICs out the other side without having human involvement and all of that type of stuff. Yeah. So wafers and design file goes in, IC comes out the other end.
Yeah.
It's not going to be competitive stuff. I mean, compared to TSMC, etc. Of course not. The node size is going to be huge, but just being able to design and manufacture your own ICs locally is going to be a huge thing.
Yeah.
Yeah.
We're near the end now. Just a few questions left. We've been chatting for 1 hour and 20 minutes soon.
I warn you, I do talk a lot.
Yeah, I know. This one is a good question, I think. If you could go back and give your younger self one piece of advice, just one, what would it be?
Oof. Oh yeah, that is a tricky one.
Yeah, yeah, it is. Just one that it could be something that steers you towards something completely different. It could be anything.
Yeah. I've been mostly. I said I tend to not really do regrets all that much. It's in the past. I can't change it. What's the point?
It's not really a regret. It's just
So, but if there was one advice I could give myself as a younger child,
yeah.
it would probably don't worry too much.
Don't worry too much.
You know, it's teenage is always a very
I know.
a very stressful period where people care about all sorts of random shit, and you look back at it 30 years later and you go, eh.
Yeah.
Just spare yourself that agony and just don't worry about it. Do your own thing. That would probably be it. Yeah.
Is there anything else you would like to talk about or add before we go to the last question?
Nothing I can think of really.
Any shout outs, greetings you'd like to send to some people, you know?
Oh yeah, I mean, hi to Bart, of course. Bill and Terry and Dave and RJ and all of the other Commodore engineers, absolutely, if you ever run across this. I've forgotten a lot of very important people. That's not a slight, but there's just too many names involved.
Age, well.
The demo scene in general, it's been a huge part of. I've never been a good demo coder, of course not, but I've always been fascinated by the demo scene, and it's fantastic to see big events like Revision still going.
Yeah.
You meet a lot of interesting people. Hi, Danko. I met him at Revision this year. And yeah, no, it's just to all the people who actually create and make things, keep going. Yeah. We're finally getting to the point where we can build open source Amigas from scratch without any of the original chips. So just keep on going, you know.
Yeah.
I'm hoping to do the same with the old 8-bit machines.
Okay, then all I can say is thanks for taking the time for this little chat, and good luck with your future products.
Yeah, thank you.